The foundation of all science and technology is mathematics, and one of the most important branches of mathematics is trigonometry. Without trigonometry, our knowledge in technology and engineering will crumble. Through trigonometry, we're able to know the height of an object without actually measuring its length.
Hello everyone! Today we will discuss the 6 trigonometric functions, how to use them, and how to find their values. So that is the sine, cosine, tangent, and their partners. We have the cosecant, secant, and cotangent. But first, we have to look at the sine, cosine, and tangent. And to easily memorize these functions, we will use our memory trick, SOHCAHTOA. SOHCAHTOA. So stands for sine is equal to opposite over the hypotenuse. Ka means cosine is equal to adjacent over the hypotenuse. And TOA, that is tangent, is equal to opposite over the adjacent. All of the 6 trigonometric functions involve right triangle. A triangle having a right angle in the corner, which is noted by a corner symbol. And this angle has a measure of 90 degrees. And we will also know where theta is. For example, our theta is in this portion. Theta is just an angle that is not the right angle in this right triangle. So, what's important to know is what each of the side of this triangle in relation to theta. The side opposite to the right angle is the hypotenuse. That is the longest side. Then the next side, the side next to theta, that is not the hypotenuse, is what we call the adjacent side. And the third side, the side opposite to theta, directly opposite theta, is the opposite side. Now we're going to evaluate sine, cosine, and tangent based on these sides. Okay, for example, you will be given a problem like this. A right triangle, right angle, and some theta. Okay, then you will be given the side lengths. For example, this is 5, the diagonal, then the adjacent is 3, and the opposite side is 4. Okay, based from our memory trick, SOHCAHTOA, we will find first the sine of theta. So, sine theta is equal to, that is opposite over the hypotenuse. So our opposite side is 4 and the hypotenuse is 5. So sine of theta is equal to 4/5. Okay, next is the cosine of theta. So, cosine theta is equal to adjacent over the hypotenuse. So the adjacent side is 3 and the hypotenuse is 5. So cosine of theta is equal to 3/5. Okay, next function is the tangent function. So tangent theta is equal to opposite over the adjacent. So our opposite side has a measurement of 4 and our adjacent side is 3. So tangent of theta is equal to 4/3. Okay, we already have the values of our sine of theta, cosine of theta, and tangent of theta. Now we can evaluate our cosine, secant, and cotangent. So by its definition, cosecant theta is equal to the reciprocal of our sine theta. Okay, since we already have the value of our sine of theta, so we can just flip the value of the numerator and the denominator to find the cosecant theta. So that is 5/4. So our cosecant theta is equal to 5/4. Okay, next function is secant theta or secant function. So secant theta is equal to 1/cosine theta. So since we already have the value of our cosine theta, so we can just flip the value of our numerator and the denominator. So our secant theta is equal to 5/3. Okay, the last function is cotangent. So, cotangent theta is equal to 1/tangent theta. So that is, tangent of theta is equal to 4/3. So our cotangent theta is equal to 3/4. Okay, another example. You're given a right triangle that is drawn in different orientation. Okay? Based on this figure, this is our right angle and our theta. So, then you're given the lengths of the sides. So, for instance, this is 7, this is 4, and this is 3. So, now you're going to find the sine, cosine, tangent, the cosecant, secant, and cotangent. So, from our memory trick sa katawa again, so sine theta is equal to, that is opposite over the hypotenuse. So our opposite side, based on this figure, is 3. And the hypotenuse is 7. So sine of theta is equal to 3/7. Okay, next is cosine theta. So cosine theta from our memory trick is adjacent over the hypotenuse. So the adjacent side is 4 and the hypotenuse is 7. Okay. 4, 7 is our cosine of theta. Next is tangent theta. So by the memory trick, we have the opposite over the adjacent side. So our opposite side is 3 and the adjacent side is 4. So tangent of theta is 3/4. Okay, now next is the other 3 trigonometric functions, the cosecant, secant, and cotangent. So since we already have the values of our sine, cosine, and tangent, it is now easy for us to solve for the cosecant, secant, and cotangent. We have cosecant theta, by its definition, that is 1/sine theta. So we already have the value of our sine theta, that is 3/7. So we can just flip these values to find our cosecant theta. So that is 7/3. Okay, 7/3 is our cosecant theta. Next is our secant theta. So that is 1/cosine theta. So we already have our value of our cosine theta. So that is 7/4. Okay. Next is our cotangent theta. So by its definition, that is 1/tangent theta. So that is 4/3.
Can we apply the 6 trigonometric functions in real-life situations? Watch this video.
Hi, my name is Bree.
And I'm Nadine.
And today we will be introducing trig functions in the real world. There are many places where one can find trigonometry. Trigonometry can be found in mechanical engineering, physics, electrical engineering, astronomy, music, biology, and ecology. Our EQ for the day is how can trig functions be applied in a working environment?
So first of all, what is trigonometry?
Well, trigonometry is the branch of mathematics dealing with the relations of sides and the angles of triangles and with the relevant functions of any angles. The 6 simple functions of trig are sine, cosine, tangent, cosecant, secant, and cotangent. One of the working environments we decided to focus on was architecture. Trigonometry is critical for curving surfaces in building materials. It is essential to find height and to create dimensional objects. Angle measures and distances are vital when creating a building that people will be using. Trigonometry is seen in blueprints to show accuracy of a prototype and will help workers to create precise construction projects that can make sure people using a building will be safe. Trigonometry is used to build arches, domes, support beams, and bridges. Nadine and I interviewed Mr. Wee to get a different perspective on architecture. He stated that, using trig, you can figure out the minimum specifications to hold the weight. Natural occurrences such as earthquakes should also be taken into consideration when finding out the maximum tolerance of the structure. He also said that all functions are important because missing a small detail can cost lives. One can also find trig functions in the medical field, specifically MRI machines. MRI stands for Magnetic Resonance Imaging. This machine is a non-invasive medical test that helps physicians diagnose and treat medical conditions. The MRI uses a powerful magnetic field, radio frequency pulses, and a computer to produce detailed images of organs, soft tissue, bone, and virtually all other internal body structures. The MRI maps the distribution of water in the body, which is 70% water. The hydrogen atoms in the water molecule have only one proton, so that when excited by a magnetic force, they create a pulse that can be traced by the MRI to create an image. MRIs use right triangle trigonometry, particularly sine. The machine also uses magnitude and amplitude. Sinusoidal waves. The MRI uses 2 magnetic currents to draw a sinusoidal wave. Over time, the magnitude decreases, causing the wave to dampen. Okay, so for our project reflection, we decided to focus on the actual making of this video, and for us it was a little bit frustrating because some of the stuff wouldn't save and it was hard to do this voiceover, apparently, because we've been doing this for like a long time. And Bree, do you have anything to say?
Yeah, we were getting really frustrated at first with saving, like Nadine said, but overall it was really fun because we got to work with different animations and figure out more information about trigonometry and how we can use it later on in our lives.
Okay.
Thank you.
Oh, we finished. Good job.
Created using Powtoon.